All right, everyone, let's get this show started. Welcome to our DevOps office hours. It's December 22nd, 2021. My name's Eric Osterman, and I'll be leading the conversation. I'm the founder and CEO of Cloud Posse. We're a DevOps accelerator, and that means that we help companies own their infrastructure in record time by building it together with your team while showing them the ropes. So if that sounds interesting, head over to cloudposse.com/quiz to get started. For those of you new to the call, the format is very informal. My goal is to get your questions answered. So feel free to unmute yourself at any time if you want to jump in and participate. If you're tuning in from our podcast or YouTube channel, you can register for these live and interactive sessions by going to cloudposse.com/officehours. Again, that's cloudposse.com/officehours. We host these calls every week. Our call today is recorded. We'll automatically post a recording of this session to our YouTube channel. So if you enjoy the content and want to support it, please hit those like and subscribe buttons. Just head over to youtube.com/cloudposse. Again, that's youtube.com/cloudposse to subscribe. So with that said, let's kick it off. I am pretty light on announcements, so I'm hoping everyone else has some other exciting things they caught that I missed throughout the week. We'll start obviously with Cloud Posse announcements, and we have, I thought it was merged, but it wasn't merged yet. We are coming out with Lambda Edge support for our CloudFront S3 CDN module. And why this is cool is, let me describe kind of the use case or problem statement. So frequently you host static sites on S3 and front it with CloudFront, and you're pretty limited in the kinds of operations you can do with that configuration. Sometimes you would like to do more advanced rewrites on the edge, and CloudFront doesn't provide any way of doing that unless you're using Lambda. A use case that we had was we want to develop preview environments for React apps. And to do that, we didn't want to have to provision infrastructure for every preview environment. So what we do is instead we deploy one CloudFront distribution, one S3 backend, and then we have our GitHub action workflows that push static sites to the S3 bucket based on branch name. So whatever the branches that you've opened for your feature, we just publish that content to the corresponding branch on S3. How do we then route the traffic from the endpoint to that path on a given host name? That's where we needed to come up with dynamic origins based on the CloudFront host name. So to do that, very simple little TypeScript we put into a Lambda, and we want to deploy that. However, anybody who's dealt with Lambdas and Terraform might realize that Terraform is a pretty crappy language to do Lambdas in the naive way. Because what you end up needing to do for most kinds of Lambdas is a CI process where you're building, downloading dependencies and building your artifact, which is this Lambda of a zip. And you got to stick that Lambda somewhere, typically in an S3 bucket or something. And doing all that in Terraform is the wrong pattern for it. But when we're dealing with Lambda at Edge, yes, you can do all that. However, for the simple case, all you need is just some inline JavaScript. So that's what this implementation is all about. You can just define your function inline, give it a file name. We generate the zip file programmatically in Terraform. We set up the attachments of the functions to the Lambda to enable Lambda at Edge. So it really makes it a very simple way to deal with Lambda at Edge and Terraform with S3 buckets for doing those simple manipulations you need to do. I see this here. So that's not missed. All right. The other thing we're working on is our Apache Airflow module for AWS, the managed workflows for Apache Airflow, MWAA. The PR hasn't been merged yet, but this is implementing a simple interface to provisioning Airflow with Terraform. And I guess the more interesting thing from this, from my perspective, is just to show how all of our modules in this ecosystem that you see here, we have some, clicked on tag instead of language here, but if we click on HCL, you see we have something like 190 repositories under the Cloud Posse organization. And almost none of these were done speculatively. These were all designed and created as a result of client engagements. So now when we do an engagement, we're pretty efficient because we have the prior art, and it's just one grain of sand at a time building up this mountain. And our Apache Airflow module is just an example of that. So we have actually 3 engagements we're working on right now where almost simultaneously they had Airflow requirements. So we're building up that module. Embarrassingly small announcement. Embarrassing because we should have had this from day one, but we didn't. So for those of you using Atmos, it underwent a massive rewrite 3-4 months ago. With version 1.0, the whole CLI was rewritten in Golang. We used this esoteric task manager called Variant in the first version. That helped us prove out that this worked, that the pattern worked and the interface worked, but we were limited in what we could do. So we wrote Atmos in Go. And when we did that, we didn't re-implement help. So, like Atmos help. So now we finally have help again. And that should make the tool a little bit easier to work with. Let's see here, what was PR here? No, not that one. So we are also working on the public open source documentation of Atmos. I don't know if there's a branch for it yet, or if Andre has pushed it up yet. No, I don't think so. But better documentation for Atmos is coming, and stay tuned. All right. Anybody using Atlantis? Yeah, John, okay. We were big users of Atlantis for a long time. I think Atlantis is a cool open source project for managing continuous delivery of Terraform. We kind of graduated from Atlantis and used some other tools like Spacelift now, but Atlantis is obviously still very popular. The biggest problem with Atlantis, and one of the reasons why we stopped using Atlantis basically 2.5, 3 years ago, is this feature. The GitHub. Wait, I linked to the wrong. I linked to the wrong link here in this. I didn't mean to link to Cloud Posse Atlantis. But this just goes to show. In 2019, we wrote the first implementation of this, and this was before the changing convention from whitelist to allowlist. So Atlantis now, though. GitHub run Atlantis/Atlantis. So with the latest release of Atlantis, you can now use allow lists with it. Where is it? Hold on, let me pull that up because I want to make sure I got my facts straight here. Atlantis, run Atlantis, PR 1694. So this was the PR that implemented it. This was the PR that was based on our original PR from a couple of years ago. It went through three attempted PRs, but finally Paul Erickson got this merged. So thank you to Paul. And what this does is, here's the problem. In Atlantis, the way it works is, or let me take a step back. For anybody not using Atlantis already, Atlantis is a tool for continuous delivery of Terraform. It is purpose-built for working with Terraform, and it implements a method of using chat ops on GitHub comments to do basic operations on Terraform, or basically any workflow you want to do. So with Atlantis, you write a comment on a pull request like slash Atlantis plan, and you get a plan for your Terraform, and you run slash Atlantis apply, and you get it to apply that plan that was generated. The problem is that until this PR, anybody who could run a Terraform plan could do anything with the credentials of your Atlantis server. And there was no way to restrict who could run a plan other than remove them from your GitHub repository. So we found this as a tremendous security concern, and therefore implemented this allowlist functionality. So you can restrict what a GitHub team can do with your infrastructure repository. So you can say, my team can plan, my team can apply, or my team can only plan, but this other team has to apply my changes. So you have checks and balances, for example. There was some initial pushback and hesitation, that this was adding bloat to Atlantis, and that it could be just accomplished some other way. There was a very long thread opened by us in 2018 on why this was such a serious issue. And I was just surprised that it was never deemed something that their answer was, hey, you could just do this in your workflows. That's not the answer we were looking for. So congratulations though to Atlantis. This feature's there. Use it or lose it, your infrastructure. For everyone on AWS, I want to introduce a new acronym. It's called YAAO, yet another Amazon outage. And that was this morning. So I guess there was a power failure. And obviously Amazon does some crazy stuff with their data centers and how it all works. I don't want to oversimplify or minimize these problems, but yet, the simple stuff brings us down every time. And I guess there was some serious cascading power outage failure that led to this outage. All right. Lastly, public service announcement. If you are on the bleeding edge of Terraform and you had already upgraded to 1.1.0 or 1.1.1, you run the risk of losing your Terraform state, kind of like Terraform being having amnesia. So they recommend immediately upgrading to 1.1.2, so you don't run the risk of losing the current Terraform state. Now, obviously, if you have versioned S3 buckets, that's less of a problem, but I would rather not even risk it. So upgrade ASAP. Any other interesting announcements? That's all I had. Cool stuff, related to AWS, GitHub Actions, stuff you're working on, projects you've discovered.
I was just going to say, I think on that last announcement, I only read it briefly before, but I think it was related to something to do with the newly introduced moved blocks. I think that was causing the problem.
Oh, interesting.
Yeah. So I didn't get to read all the code, but I think from what I read, that was that's what it looked like.
The root cause.
Yeah.
Yeah. Any other interesting things you came across your radar, Matt?
Pretty boring week.
Yeah.
Not much going on.
It's a pretty bad week to announce anything, right? Like half our customers are out for the holidays, etc. So okay, let's just jump into some Q&A. We were scouring. If you haven't yet posted any questions in the Office Hours channel on Slack, that's the best place to do it. Or for the rebellious ones, you can always post it in the Zoom chat like Eric Berg. No, I'm joking. Eric, what are you saying here? We're looking for a service to check DNS registration expiration and SSL certs across registrars and CAs for only about a dozen domains. I've seen all kinds of things. I've seen like Slack bots in the Slack marketplace that'll do similar things. I think the best way of doing this is going to be dependent on what you're using for monitoring today. Are you using Datadog today or using CloudWatch, Eric? I forget.
Datadog. Can you hear me?
It's very faint. Is that just me or everyone else? Raise my volume.
Oh, he's very faint.
How's that? Is that better?
Yeah, now we got you loud and clear.
We're Datadog Shop, yeah.
Yeah, so I mean, I would just then go straight for one of the Datadog methods of validating it.
But you have to have the metrics in there. Oh, okay. So this is one of the Datadog checks that's actually going to go out and look at things. I'll look at that as
Yeah, I mean, unfortunately, this would be running
right.
in one of your agents configurations, and I don't know if there's another way, possibly like in synthetic or something that you could do it.
No, not with synthetics. I looked. That's pretty buttoned down to HTTP kind of stuff.
Yeah, that's what I would have hoped, but yeah.
I kind of wanted somebody where I could like upload a little CSV and be like, let me know if there's a problem, guys. Rob's going to give you 50, $250 a year.
Oh, there are services like that. But I got to call you out. Is this in response to actually an expiration? It happens to the best of them, you know. Yeah, our cert for our.
I go so far as to almost say it happens to everyone.
Yeah. Yeah,
It's like a rite of initiation or something, you know.
It is a rite of passage. Hey Zach, I haven't seen you for a while.
Actually, if you just use a regular Datadog HTTP check,
And then
there's a property on there that says like check _certificate _expiration. You set it to true, and it will tell you like when the. I think I think that's actually going to only tell you if it is expired, not like
not preemptive. Yeah.
Right.
Oh no, here it is. No, I was wrong. There's days warning and days critical as well for certificate check. So you can set how many days.
But it is on the agent though, right? It is at the agent level. So you have to have an agent deployed somewhere to do this, meaning delegate some host on your network to run that agent and make that the TLS checker.
You can do this easily if you have metrics for this. Like I have a ton of Route 53 stuff and all that's in there. I've got dashboards and monitors, but like marketing created some stuff and they didn't exactly put it in Terraform.
No.
Or use like a standard, CA or for the certs, whatever.
Yeah, I mean, okay, so let's say, I mean, either way, I think there should be a fail-safe to monitor TLS certificates, even if you're using Let's Encrypt and, you have this fancy swancy automatic renewal stuff, we use that everywhere. You can still have problems preventing renewals. So yeah, monitoring for TLS validity is critical. But the next thing is like, what are we doing where we, where that makes it even more important to have it in place, like self-signed, or like not self-signed, but self-managed certificates from, a CA rather than ACM, for example. And can you move to ACM in other words, or use Cloudflare, right? Like make this a non-issue. Cloudflare will, renew your certs in perpetuity and not worry about it.
Well, that's just the Cloudflare certs. Well, it's like, yes.
But your origin doesn't need to be necessarily signed, right? So, I mean, it doesn't hurt. And it's definitely another layer of security, but you could get away with expired and self-signed certs together with Cloudflare, for example.
Right. Yeah, we have, even at our small, even at our size, we have like 4 or 5 different places we have to go for each thing, and I just don't have the resources. So just looking for a tool if anybody knows one. Thanks for considering.
Well, let me see it here. Slack, Slack app monitor.
Yeah, chat. Yeah.
Yes, because I did come across this some. SSL certificate. Track SSL, that's the service, I'm pretty sure, that you're looking for. And I think they also have a Slack app. There you have it.
Cool. Thanks.
Post that in office hours here. All right. Next question. I'm gonna take priority. Has anybody played with control tower customizations in any capacity before? I'm just really curious about them. Zach, have you played at all with them? Eric, I forget, are you using control tower?
I have not personally, if you're asking this Zach. But no,
Yeah, that's Zach. Yeah.
no, haven't had the opportunity.
Yeah. All right. Yeah, I'm really basically this is a way for you to add feature flags to your organization's control tower so that users can, requesting accounts can add features at launch time, and then you can provide ways of ensuring that those customizations are implemented. So we're looking into that. All right, next question. Sharif, do we have you on the line today?
Yeah, I'm here.
Oh, awesome, awesome. So you posted a long question on sweetops. Let me pull that up. Conversation. You want to have a conversation about ingress controllers and how to choose between them. You mentioned that you've tried a few of the, you tried a few of the 200 ingress controllers out there, and for practical reasons, you're confused kind of which way to go. And while the AWS ALB ingress controllers makes perfect sense when you think about latency and reliability, and especially if you're operating on AWS, it might not offer all the robust and awesome features that you get with some of the other like vendor controllers out there. So like Ambassador or Istio or Traffic and Kong, and the list goes on and on. So for example, there are ingress controllers that specialize as an API gateway. We're talking now about Ambassador, and some integrate with other components like for Argo rollouts and Flagger to do advanced rollout strategies. Now, there's obviously Nginx's tried and true ingress controller, which was the de facto ingress controller for Kubernetes in the heydays. Now, now I think most of us have moved on from Nginx as well. Also, like what's pretty cool, like if you're using Nginx ingress, there's also open REST, so you can do some pretty advanced ingress level API gateway type of stuff with Nginx ingress. So you mentioned here with an in-cluster ingress, unlike the ALB, you have to carefully spread your workloads across the cluster to decrease latency. This is a good point. Basically, the ALB is intelligent enough to try and reduce, the ALB works directly with your pods versus every other ingress controller doesn't work with your pods directly. It works with the nodes, and then the nodes themselves load balance to the pods running on that node through node ports. At least that's what I've seen typically how they work. So now the problem statement. So Sharif has a problem that he's unable to formulate an opinion without some of the hands-on experience for larger clusters like 500 plus node clusters. And you can't rely on your laboratory benchmarks because it's too sensitive. What do you mean by sensitive in this case?
Yeah, so like if I'm trying to measure the latency, they usually like 1 millisecond difference. So I can't like have like, and it's very sensitive. Like some requests takes like extra 5 milliseconds. Sometimes.
Oh, okay. It's very, it's volatile kind of. You're not getting a consistent benchmark response. Yeah.
So basically,
I mean,
results are the same. Like all the ingress controller have the same performance for me. So.
Well, and the other really important thing to consider is how you do testing, though, is almost as equally important to how you measure or what you're trying to solve for. So I think, but so I understand, is the application that you're solving this for incredibly sensitive to latency, and that's why you're doing this, or what is the fundamental problem of why Like, why do you even have to look elsewhere? Why not just go de facto with ALB load balancer controller? You're operating in AWS. Why look
Okay.
anywhere else?
Yeah, so the ALB Ingress controller like makes sense, makes perfect sense, but like where I work, we need some of the API gateway features like the authentication and stuff.
Mhm.
So we have AWS API gateway before the Ingress controller, and I didn't like it because it's getting messy in the configuration because I have to like
Mm,
do the routing in the AWS API gateway configuration and
yeah,
still do it again in Kubernetes. And
yeah.
like especially that we have dynamic environments and view environments and stuff. So like I'm coupling the like Terraform will do the API gateway changes.
Mhm.
Helm will do the Kubernetes configuration for the Ingress controller,
Yeah.
and it is not very like the developer experience is not very good. Like if I want to add a route, I have to add it in two places. I have to configure it in two places. It's not very
Understood. Yeah, and that's an important part that goes into this consideration. So there is no one size fits all, and like you said, it should just be a conversation based on your requirements, what load balancer controller you want to go with. So I think the other consideration here that's really important is that this decision that you're looking up is not mutually exclusive. A cluster can have 10 Ingress controllers
yeah.
deployed, and you can have
Yes.
different Ingress classes. And that's a good thing, because now I would say this is a somewhat reversible decision. This is somewhat, this decision you can now decide on what makes the most sense for those services where this is even a factor. And just since you need it for those services, why not maybe use ALB for everything else? Maybe the ALB load balancer controller is the best thing for all your front end apps, but maybe you need an Ingress controller optimized for API gateways, for API kind of backend services, and you can use a separate controller for that. And then you get part of your workload off of these self-managed services and onto these managed services like the Amazon load balancers. The other consideration, and this is something that we've had to deal with our customers, is the cascading consequences of your decisions. Like if you decide to go with a load balancer other than the ALB, you are now saying like you don't want to use AWS WAF anymore, for example. But if AWS WAF was a requirement, then you got to reconfigure, rethink some things. If you need to have TLS encryption end to end from the client to the pod, well, then suddenly the Amazon load balancer controller, it can do it. It's just now you're still in the business of managing the TLS at the pod level, because from the load balancer to your pod, it's by default not encrypted. So is end-to-end TLS one of your considerations as well?
Not currently, no.
Okay. Then go on, Matt.
Sorry, I was going to say there's one other possibility that you could look at. They have the AWS controller for Kubernetes, and you can actually create and manage the API gateway with that controller. So you can actually do it all in Helm and only have one place to update and manage all of that stuff, so that you don't have to then do that in Terraform and Helm for that piece. I remember there's actually an article, I think, specifically about how to do it with API Gateway and the
Is
ALB
it like
controller
cool to
together.
me.
Is it like an Ingress controller that uses API gateway
No,
as its load balancer, or is it something like uses crossplane and the IAC stuff?
You got to look it up, Eric. Okay, there you go.
well, yeah. What was the? I forget what it.
I think it's the AWS controller for Kubernetes.
Yeah.
I think that's
So
what it's called.
this controller went through like 4 names, and this is the
Yeah.
final one.
Yeah.
They used to, yeah. So with this one though, you basically get custom resources in Kubernetes that you can use to define things that are infrastructure level at the AWS place. So it's the glue, so to say, between those. And these are not those. Let's see here where the example is though. Yeah, so resource adoption, this is a design proposal. Was it adopted? Oh, that's to import, I guess. No, I misunderstood. Maintenance phase, it's in preview. If they have an example of what a resource would look like. So yeah, they've implemented support for these resources.
Yeah, but I'll still have to like glue it together with my Ingress controller. It is not an Ingress controller by itself. Like I will have to put it in front of my load balancer.
Yeah, it's just that because they are in the same technology stack, in the same, like both Kubernetes manifests. For example, let's assume you were doing this with Helm. You could now make sure that when you are describing the resources for your ingress, you're also describing the resources for your API gateway in the same manifest. So when they get applied, they're applied at the same time.
Yeah, I get it.
Yeah. So I think that, yeah, I think that's one good idea, Matt, for sure. That sounds interesting. Other consideration. So what is, what is an API gateway solving? And that is one way of solving complex routing for requests to backends, as much as that's also what service meshes are doing. So I'm not sure if AWS App Mesh would also be able to help with some of that as an alternative implementation instead of using API Gateway for this particular service. I don't though have enough App Mesh. I don't have any App Mesh experience, to be candid. So I don't know if you can authenticate, edge requests up an Ingress working with App Mesh. Somebody else might know more.
But my idea was actually like I was trying to like get rid of having to have like any AWS resources. Like if I can do everything from the Ingress controller, it would be like at least from if I'm looking in the network stack, it is much simpler. Like if I'm gonna explain it for some of our team or for our developers, it will not be very complicated. Like so I only want the API gateway for the authentication. Like the Glue Ingress controller have implemented they recently released it. Like they can execute Lambda functions like the API, like the AWS API gateway. And it was gonna be like very, very good for me. Like if I have everything in the cluster, everything in Kubernetes, one less network component that I will not worry about.
But I missed the first part there. If you're not using API Gateway or ALBs, how are you executing Lambdas?
I am using API Gateway, like the API Gateway.
Yeah, exactly. But if
like
you,
API Gateway, so the API Gateway have a private link to our application load balancer, that is the Ingress controller, and we configure it with Terraform to just pass the authorizer Lambda function and do the authentication. Actually, most of the traffic, like I only like actually the traffic routing based on the host names and passes has to be done in post, like in the API gateway. In the API gateway, I only have to do it so I can declare what passes need to pass through the authorizer and not. But the rest of the routing to like which service and which Kubernetes service I have is all done through the Ingress control.
Understood,
so, like I'm using the whole API gateway and I'm doing all the glue code using Terraform to make it work. Like if I only was able to get it into Kubernetes, it will be much simpler. So that's why I was looking into it. However,
does the
like
API gateway configuration need to change that frequently? I mean, can't you just have wildcard that goes to Kubernetes and authenticates every one of those requests? So I mean, it's really just a cold start, making it more of a cold start problem than an ongoing problem.
Actually, for production, it's not changing that often. However, we have dynamic environments, and like, like the dynamic environments needs to create an API, like all the integrations and routes every time a service is deployed.
Yeah.
It's getting messy because of the requirement of the dynamic environment.
Maybe though, that's where you could do better rules. So you can have one rule that rewrites automatically based on host names to the backend environment. So you don't need to provision a new rule for every environment.
Yeah, we actually do this. Like our
Okay.
Lambda, like our Lambda authorizer function will do host matching and talk to the correct environment identity provider, and like we are not having like like an API gateway stage for each environment. We only use the default stage, and most of the routing is only done through Kubernetes. So we limit all, like we like 90% of AWS API gateway features, we are not using it. We are using the Ingress controller, except for the authorization.
Makes sense. Anyone have any else they could add to this? Things to consider? All right. Vlad had a lot of other things to add here. Vlad has always really interesting insights. Unfortunately, I didn't get a chance to read through them all yet, but I'm guessing, Sharif, you did have a chance to review. All right. Sean Turner asking, anybody running Spark on Kubernetes? We don't have any experience with that, so anyone? Or no one? All right. Let's see here. So in Zoom, any questions? Chat. Nothing there.
I actually, to make up for my earlier transgression, dropped one into office hours.
Yeah, okay, sweet. So Eric Berg says, I have 3 different resource usage profiles amongst the Kubernetes services and jobs that you run. You want to isolate the pods with erratic resource usage from the front-end pods and also run jobs on spot instances. Should I use node groups to do this? Should I use should resource limits be enough? So basically you have some, I guess there's a couple things to consider. Are you doing this because you have observed that you have these kind of chatty or noisy neighbor problem affecting other pods running on the same hosts when they're scheduled?
I'll start this way. I think I've convinced the other people involved here that the idea of ephemeral infrastructure and container management really does lead you ultimately to killing pods that fall outside those resource limits, across the limit.
Yeah.
The answer at one point is like, gee, I don't know what happens when we get an OOM. I'm like, well, freaking figure it out, dude. We gotta like,
yeah,
because this is really a couple different questions, right?
Yeah.
The first question about load is, if I just size them properly for the node, they should be able to go nuts with every one of them, assuming you're going to do it this way, to their maximum, and nobody knows any of the better.
Yes.
Right? That's like the idea here, right?
Yeah.
Okay. Thank you for confirming.
No, you confirm. Yeah. And this, just to add, as soon as one starts messing around with taints and tolerations, and figuring out where you want to place things, you are kind of overruling. You're using your veto power over the Kubernetes scheduler to get your mission done, but introducing new problems that you can't anticipate. So the more you can offload to the scheduler, so it can use in its infinite wisdom and understanding of where to put pods, that's what you want. That's what your goal should be. Now, if you I could understand if you were doing some, mission critical, high frequency trading, and you absolutely your risk tolerance for any disruptions or increased processing time was 0, then yeah, why don't you create specific classes of instances that specific reserved node pools for those workloads, but in general, try to avoid it.
Yeah, agreed.
And don't do it until it's a problem. Like,
Right.
no, avoid premature optimization. And this is one of those things often I see like that talking with customers, they're thinking about how they were doing it with classic auto scale groups and their other infrastructure, and then they're applying those concepts to how they're doing in Kubernetes. Well, maybe those aren't even going to be problems. I'll mention one other thing that's a consideration. Like if you're dealing with WebSockets, that's a big deal. And if your app is very sensitive to long-lived WebSockets and you're doing kind of asynchronous communications, and if the socket client isn't connected and they miss a message, that's a bad thing, or the UI hangs for periods of time when that happens. And basically, you want to operate a more stable tier for long-lived persistent connections. I think that's a really good use case for creating a separate pool. Were you the one who asked about that too, or does somebody that came up on office hours before? Like, what do you do when you have that problem?
Well, I don't think that was, but right now I also want to. We're managing the 3 nodes in each of our environments with just a tagged autoscale group. So I'm going to move those to node groups just for a good, management, better integration with AWS. So that's going to also allow me to just like say, hey, you know what? New node group, spot instances, run jobs when you can for free. I think that's a good use case for that.
That's a good one, yeah.
But it actually is much less work and totally aligned with my take on things, which means in terms of like we just need to look. So we're greenfield, like we've been talking since before I had any of this stuff, and I was like, you know what? We are gonna have full-blown graphing of all of our resources, and we'll know. Let's stop theorizing. I'm not even gonna talk to those guys. And now I bring it to them. I'm like, here's where we should kill this guy. Here's where we should kill this guy. We can squeeze this. So I think that's the route we're going to go. But thanks for entertaining the idea.
Yeah. So, sorry. I was just going to add. I was going to add one thing just about how you said, that taints and tolerations are like a smell, basically, or I'm paraphrasing. I would say the only time that I would disagree with that would be if you have specialized resources, you have GPUs as an example, or some some things are on SAN storage versus local attached storage, or something along those lines. Or if you have certain nodes that you just want to run load testing on, or integration tests or that kind of thing, and you don't want production loads to run on them, then those are all really good uses of taints and tolerances. So just making sure that we weren't saying never use them.
Thanks for backing that. I agree. Basically, if there are other hints that you need to give that the scheduler won't know intuitively, for example, the GPUs and things like that, that's the cut and dry use case for that.
But also don't be afraid to set scheduler policy as well to tell Kubernetes what things are more important than other things in the case that it can't schedule everything, that your most important services don't get preempted for something that isn't important.
Speaking of that, one of the things I ran across was it called undeployer or something like that? It's that kind of a
The descheduler?
Yeah, maybe it is the deschedule. That sounds right. But basically, you can implement triggers so that it'll for instance, when a pod is violating or is in violation of its affinity or non-affinity, anti-affinity rules, it'll reschedule it, which is great because we're sitting there I'm no, stop killing stuff. It'll do the rebalancing. And
that's what the
second box popcorn. We're waiting for that. What is that, Eric?
Yeah.
That's what this helps with. Yeah, rebalancing your clusters.
I think that that is a really, like, I can't believe I didn't find it till like 2 weeks ago. That seems important.
Yeah, I mean, there are also other considerations like, you know, trying to keep things stable. The more, you know, like like the pod disruption budgets are there for that reason. So I think that's why it doesn't always just rebalance.
Mhm.
Yeah,
Let's
they
try-
also, there's a cool policy in that scheduler thing that has a like remove pods that have too many restarts. So you don't, like, if you have one that's constantly crashing, you basically can just have it not schedule it anymore until you fix it. Like, so it doesn't replicate itself to every pod or every node in your cluster to try to start itself.
Does descheduler do that, or is that another
Yeah.
controller?
No, descheduler
okay.
has that policy that you can
Okay.
apply, which is
A bunch of neat stuff in there. I think somewhere on that page is a list of just like, you know, use cases.
Yeah. I was trying to find, there was one other thing that came out of reInvent. There was a new controller for EKS, and it allows you to basically, it'll right size every node launch.
Yeah, Carpenter. It's called
Carpenter. Thank you. Thank you. I was trying to find that one.
It's actually very interesting. I read about it and I actually wrote read the source code. It's not there yet, like it is, but it has a very good premise. Like it's very useful.
So we've been using Spot IO, which has their Blue Ocean controller, and it implements this this strategy. Basically, in Kubernetes, using an auto scale group, diminishing returns. Right. The auto scale group is a construct in Amazon to scale a resource. But that the operator for that, or the brains behind that, isn't even really used by Kubernetes. And Kubernetes is that with its own scheduler. So instead, have Kubernetes directly launch the nodes, almost like the Jenkins ability to launch.
Can't hear you.
We can't hear you. Yeah.
Eric, if you can hear us, we lost you.
We can see you, but can't hear you.
All right, can you hear me now?
Yeah.
Yeah.
All right, cool. Yeah, back on my MacBook here. So yeah, in this model, Kubernetes can just schedule nodes directly on demand as it needs them for exactly the type of resources that it needs. And that I don't know how maybe in your specific use case it could help alleviate any of those problems, but it'll help you right size your fleet of nodes.
And it actually uses the labels, like if you want an ARM instance or
Oh, cool.
or an instance with a GPU, you just put a label. You don't have to like define auto scaling group for everything.
Yeah.
But it still has some missing features that it does not support volume affinity. So if you are using any stateful sets and or any volumes, any BVCs, it will not do like the autoscaler will do. Like it chooses the auto scaling group that fit the availability zone you want that has the BVC.
Yeah.
And
Pro tip, use EFS, but yeah, for where that's not practical. Yeah.
And like if you check the concepts, they have like two controllers that will provision the pods now, and there is another controller that will redistribute the pods so you don't have a lot of defragmentation and like.
So are you saying like almost like what the descheduler does?
It's not implemented yet, and it is very critical. Like I tried to imagine how Carpenter will be used in our clusters, and it will generate a lot of nodes, and over time we'll have a lot of unutilized resources.
So could you then do the descheduler with Carpenter?
Yeah. But Carpenter is much smarter. Like it's using I don't know what the algorithm is called, but it has some smartness, like how to choose the right node sizes, to like not have any fragmentation as much as possible. The guy that's leading the project, at least like online, Justin, is very active on Twitter and has lots of insights on the and the roadmap they are trying to achieve. And actually, it's not like it's not only for WikiS or AWS. Like the code itself is designed to be for any cloud. They have all the interfaces and set up, but they only implemented the AWS interface. And they expect the community to like implement the Google Cloud and Azure and the other cloud providers.
Very cool. Yeah, thanks for that background. I didn't know any of that. All right, any other questions? Eric, thanks for that. That was a good one. Anyone else? Questions?
I have a question, like
Yeah, go for it.
there's an interesting problem like I faced lately. Is there any way that we can throttle the IO for each pod? Like, I have
Throttle
this,
IO for each pod. Yeah.
because let me explain the problem. That we have a service that writes lots of logs, like a very huge volume of logs, and they usually get affected because they like use all their storage. However, they like throttle the IOPS of the ABS volume in each node they work on. So the storage itself is not a problem. Kubernetes will protect itself. It will evict the pod when the pod generate a lot of logs, but it will be rescheduled, and eventually they make the volume IOPS throttled.
So feels like you should be able to use the sysctl type interface to restrict what the IO would be of a pod, I thought, but I haven't tried doing it.
And I don't know how it will, like, it is not the pod that is writing the logs. It is the engine will be like redirecting the standard output to file. So I don't know if these IOPS will be counted
Oh yeah.
on the process of the container, or is it just
Yeah.
on the host? Like,
Yeah, I think that's the bigger question, I think, is whose quota does that go against?
yeah. So the storage, like if you check the Kubernetes code, the storage is actually, if you said like you only have 20 gigs of storage, it will calculate the logs volume, including, like, it will include the logs in this storage. However, the IO, I don't have any idea.
Because this was what I was thinking of, the security context setting some of these limits, and if you could find something that matched what you needed, that would kind of do it. But I don't know if that, yeah, to your point, whose quota is getting consumed by that?
Yeah, exactly. It is a very annoying, noisy neighbor problem, because like I can't even like kill it or like what we can do, like make it restore quickly, like faster, like only give it like 1 gig of storage, but you don't fix the actual problem. Like I'm making it get evicted sooner, but it's still consuming a lot of IOPS.
Yeah, I don't have any other ideas. Anyone? No. All right. Well, if you figure that out, check back in next time.
Sure.
Yeah. All right. Well, we are basically out of time for today. Thanks everyone for all your insights and awesome questions along the way. Sorry about last week. Right at this time was when my computer blue screen. So, we made it. I didn't blue screen this time. So much for Mac stability. So, if you haven't yet subscribed to our YouTube channel, head over to youtube.com/cloudposse. Again, that's youtube.com/cloudposse and subscribe. It helps us out a great deal. You can always catch up on our back episodes by going to podcast.cloudposse.com. All of our past episodes are syndicated there. And connect with me on LinkedIn if you haven't already. Go to linkedin.com/in/Osterman and look forward to staying in touch with you. Take care, everyone. Have a great holiday season if I don't talk to you before then, and adios.
Thank you. Bye.
Thank you.